Okay, so now we're going to learn about reactions of alkenes and alkynes. I'm going to just start off by prefacing in that this is not all of the reactions you can do with alkenes and alkynes. These are just the ones we're going to learn in this class. It's kind of the first reactions that you learn to understand the kind of the reactivity and how they work. For example, the reaction that I'm currently studying in my graduate program in my research is an alkene addition reaction, what we're just learning about, but it works in a little bit of a different way. But these reactions are still being developed even today as you're watching this video. Someone is working on another reaction on an alkene, learning how it works and how to make new ones. So we're specifically going to be talking about addition reactions. What this means is that the reactants are added to the double or triple bond. Addition reaction, you add your reactant across the double or triple bond. This typically requires a catalyst, but you'll see that not every single one has to have a catalyst, but in most cases we have a catalyst. So we're going to be learning 4 different addition reactions. The first one is called a hydrogenation. And in a hydrogenation reaction, you add hydrogen across your double bond. So hydrogen is the root of that name. Hydrogenation is addition of hydrogen across the double bond. Then we also have hydration. Whoa, let's try that again. Hydration, which is the addition of water. So when you hydrate yourself, you're adding water to yourself. When you hydrate an alkene, you add water to an alkene or an alkyne. Okay, and then our third one is called a hydrohalogenation. So you see you have a hydrogen, and a halogen that you add across the double bond. So you have addition of HX. And then our last one is going to be a polymerization reaction. This one, the polymerization reaction, we are not going to learn in this section. We'll learn it a little bit later. I think about a week from now, we'll learn polymerization reactions. But in this section, we're going to be talking specifically about our first 3, hydrogenation, hydration, and hydrohalogenation. Okay, so let's talk about our first one. Our hydrogenation reaction is our addition of H2, our addition of hydrogen. Okay, so how this is going to work is we're going to have our alkene or alkyne. You add hydrogen plus H2 yields. I'm sorry, we need to add in one other thing. So we have yields, and we need our catalyst in order to do this. So we need either platinum, nickel, or palladium in order to do this. One of those solid metals will catalyze a hydrogenation reaction. And then from there, we end up with an alkane. So pay attention, we have alkene or alkyne ends up as an alkane. So double and triple bonds turn into single bonds. So an example of this with an alkene, we have our alkene plus hydrogen with a platinum catalyst, and that ends up yielding, so let's put our carbon-carbon line. I'm going to draw out the hydrogens for this reaction just to be very explicit with you. But where that alkene was, we're going to have a hydrogen added to either side. So those are the 2 hydrogens we added. If we have an alkyne, we're going to add twice. So we add once to make an alkene, and then we add a second time to make an alkane. So if we had our carbons We're just going to make a real long line. We had one set of hydrogens. So after the first reaction, it would look like this, where you have an alkene with one set of hydrogen added. However, it's going to keep going because you can also hydrogenate an alkene, and you're going to go all the way to the alkane. So you're going to fully remove all of the double or triple bonds, all the multiple bonds, and replace them with alkanes in the same place. So an example of this, if we have this alkene here, this actually has two alkenes in it, so we need 2 times the amount of hydrogen. We have our palladium catalyst. Okay, and then we would have, if you are drawing it completely assuming all hydrogens there, this is our answer. We just get rid of our multiple bonds. Okay, our other example over here, we have this triple bond here and a double bond here. So we need to get rid of 3 bonds. So we have 3 equivalents of hydrogen. So our answer is going to be the same molecule minus all of the multiple bonds. So that's our answer right there. We got rid of, or we added, whoa, how did I do that? Go away. Go away. I want this one. There we go. Okay. We put hydrogens in the place of our multiple bonds. Okay, let's do some practice with this. So pause the video and go ahead and try getting these answers on your own. And then we will, I'll go through the answers right now, but pause your video, do it on your own, and then I'll write out the answers. Okay, so let's look at these answers. We have this alkene here with 1 equivalent of hydrogen and our platinum catalyst. That ends with our alkane. Going down and to the right, again, we have an alkene. We're going to put hydrogens across that alkene. Let's go ahead and add in our hydrogens that we're drawing. I like that better. Okay, so on this first one, we draw the same carbon base. And we're going to draw to show that we add those hydrogens in there. Okay, let's do the second one. We draw the same base, and then we added hydrogens where the double bonds were. Okay, we have an alkyne now. A tip for this is to count your carbons. 1, 2, 3, 4, 5 carbons. Since we are changing our geometry because we don't have alkanes that are straight lines like alkynes are, they're not linear, we need to make sure we draw a 5 carbon chain. 1, 2, 3, 4, 5. Okay, and then let's draw in where those hydrogens went. Okay, so on carbons 2 and 3, they each added a hydrogen. Okay, and then this last one here, where our alkene was, we have our hydrogens. Okay, those are our answers. Hopefully you guys got them. Let me know if you have questions, and we'll go over our next addition reactions in the next video.